like real fast. And then I guess maybe we need to like just get even bigger casting machines. Sure, why not? You know, down, yeah, let's 50,000 tons.
A massive die casting machine the size of a house that can produce a new Tesla every 5 seconds. Elon Musk calls it a giant version of a toy model factory. This beast can cast 5 vehicles at the same time. Oh my God, it sounds unbelievable, but it's absolutely real. Tesla is the first company in the world to use a Giga Press and integrate it into an electric vehicle production line. While other automakers have tried to follow suit, none have been able to catch up because Elon Musk keeps upgrading the machine. It started with the 6,000-ton Giga Press, used to produce the rear underbody of the Model Y. It replaced over 70 individual parts with a single solid aluminum piece, dramatically simplifying the assembly line. Then came the 9,000-ton Giga Press, specially designed to cast the body of the Cybertruck. Massive in size and made with stainless steel, the 9,000-ton press was already huge. But what about the upcoming 50,000-ton Giga Press? Just how powerful will it be? What new Tesla vehicle is it being built for? How could it possibly cast 5 vehicles at once? Let's dive in and find out. Welcome to Tesla Car World. Before we go any further, let's break things down for anyone new to the Tesla Giga Press. It's a type of high-pressure die-casting machine that Tesla sources from an Italian company called Idra. The story began when Elon Musk was working on the Model Y. Tesla wanted to revolutionize the way the Model Y's underbody was made, but they didn't have the right equipment. Elon Musk reached out to the top die-casting machine manufacturers in the world. Only one company, Idra, was secretly working on building a gigantic press. And by sheer coincidence, it was exactly what Elon was looking for. It's used to produce large vehicle components, especially the underbodies of models like the Model Y and Cybertruck, as we mentioned earlier. The working principle of the Giga Press starts with melting aluminum alloy at extremely high temperatures in a smelting furnace. The molten aluminum is then poured into a metal mold shaped like the part being manufactured, such as a car's chassis. The Giga Press applies ultra-high pressure to ensure the molten aluminum fills every tiny detail of the mold perfectly, leaving no defects. Once cast, the part is evenly cooled, causing the aluminum alloy to harden into its final shape. This process requires extreme precision. If it's too fast, air bubbles can form. Too slow, and the aluminum starts cooling before fully filling the mold. The cooling process is carefully controlled through a uniform cooling system, which helps the final product achieve high strength and accuracy. After cooling, a robot extracts the part from the mold, trims off any excess material, and sends it through a quality inspection process. The Giga Press plays a crucial role in reducing vehicle weight, increasing structural rigidity, and boosting performance by casting a single large component instead of welding together dozens of smaller parts, saving both time and labor. Today, there are various types of giga casting technology from multiple suppliers on the market. Aside from Tesla, companies like General Motors, Hyundai, Volvo, Zeekr, and XPeng have also invested in this tech. Notably, XPeng has invested in a 16,000-ton Giga casting machine. When Elon Musk first mentioned the 50,000-ton Giga Press, the first thing we thought about was just how massive it would be, where Tesla could possibly install it, how long it would take to set up, and how on earth it could produce 5 cars at the same time. Yeah, you know, this is a pretty extraordinary machine. With the deployment of the 50,000-ton Giga Press, Elon Musk said the new production line will be so fast that humans won't even be able to keep up. Every step, pouring the metal, cooling the mold, and separating the part from the mold, will be fully automated. Each cycle takes only about 5 seconds, meaning the frame of a car can be completed in the time it takes you to blink a few times.
The design of the CyberCab line, it doesn't look like a normal car manufacturing line. It looks like a really high-speed consumer electronics line. It's, in fact, the line will move so fast that actually people can't even get close to it.
You can imagine that with the 50,000-ton Giga Press, it could easily be as large as a 2- or 3-story building laid on its side. Tesla might need to build a dedicated facility just to house it, possibly with a specially reinforced concrete foundation several meters deep to handle the weight. Compared to the current machines like the 6,000-ton and 9,000-ton Giga Presses, This new one delivers around 8.3 times and 5.5 times more pressing force, respectively. It's estimated that the 50,000-ton Giga Press could be about 20 meters long, 12 to 15 meters tall, and around 10 to 12 meters wide, weighing over 3,000 tons. The operating mechanism of the 50,000-ton Giga Press isn't entirely different from that of the 6,000 or 9,000-ton models. First, the process still begins with preparing the materials. Tesla will melt down new aluminum ingots along with leftover aluminum from previous castings in a furnace heated to around 850 degrees Celsius. Then, any surface impurities are removed before the molten metal is transferred via heated pipelines to another sealed furnace, which maintains a temperature between 750 degrees Celsius and 850 degrees Celsius. From what we know, the Giga Press uses a two-furnace system to process the aluminum alloy. One acts as a melting furnace, powered by natural gas and operating at around 850 degrees Celsius. The other stores the molten metal and is electrically heated, maintaining a temperature between 750 degrees Celsius and 850 degrees Celsius, as mentioned earlier. The empty space inside the holding furnace is filled with nitrogen gas, which helps prevent the formation of oxides in the molten aluminum. It also helps maintain a consistent temperature. Additionally, operators use argon gas, a rotary degasser, and a silicon carbide filter to remove further impurities and particles larger than 25 microns. That covers the material preparation stage. Next up, mold preparation. Before each cycle begins, the Giga Press lubricates the mold surface. A robot sprays around 35 milliliters of soybean oil in a thin, even layer across the mold, kind of like greasing a baking pan, to make it easier to release the part afterward. Then the system creates a vacuum to remove any air, and the molten aluminum is transferred from the holding furnace into the Giga Press's shot chamber. There, the molten metal is injected into the mold cavity by a high-speed piston. That piston is also lubricated with about 8 milliliters of oil before each shot.
In a single casting machine, we could do like 5 at a time or something, you know? I'm trying to think, like, how do you scale castings? Because you got liquid metal, metal's got to cool, and then you've got to automate, getting all the bits and pieces off the casting so it's usable.
After the aluminum is injected, it's left inside the mold until it solidifies. The casting is ejected from the mold at around 400 degrees Celsius. Then, the raw casting is placed into a cooling bath to quickly bring the temperature down from 400 degrees Celsius to about 50 degrees Celsius. This rapid cooling helps eliminate certain defects and enhances some of the material properties. Finally, the opened mold is cooled down to around 185 degrees Celsius and thoroughly cleaned by a robot to prepare for the next cycle. The next casting cycle typically begins about 1 to 2 minutes after the current one finishes. Any excess metal is trimmed off and recycled for the next melt. The final product is X-rayed to ensure quality and structural integrity. One of the biggest challenges during the casting process is keeping the mold from bursting open under the intense pressure of molten aluminum injection. That's why the machine must apply extremely strong clamping force to hold the mold tightly shut. And with the 50,000-ton Giga Press, that clamping force is absolutely massive.
So, I mean, we got to jam the liquid metal in, cool it down real fast.
According to Elon Musk, to make this all possible, Tesla had to design an ultra-fast cooling system, a smart mold release mechanism, and an AI-powered automated quality inspection process, a combination of technologies that no other automaker has ever attempted to implement at this scale. This also marks the first time the auto industry is shifting toward a production model that closely resembles electronics manufacturing, fast, streamlined, and with extremely optimized use of space. Beyond acquiring the new 50,000-ton Giga Press, Tesla's head of design and VP revealed that the rear Giga cast section of the new Model Y has been significantly redesigned. The rear underbody is now 7 kilograms, about 15 pounds lighter than the previous version, and requires 50% less machining time. This 15% weight reduction improves the car's performance and range, while also increasing the rear structural rigidity, helping to reduce body twist during sharp cornering. In an interview, Lars shared that the Giga casting process has seen major improvements since 2020. Tesla now uses conformal cooling, an advanced cooling technology where the cooling channels follow the contour of the mold cutting cycle times from 170 seconds down to just 75 seconds on the 6,000-ton press. Thanks to that, the Model Y is lighter, more precise, and more consistent. Surprisingly, Tesla didn't use front Giga casting for the new Model Y, a curious move considering Tesla pioneered the technology and yet chose not to include it in one of their core products. Lars Moravy explained that most current Model Y production lines still use stamped sheet metal for the front section of the vehicle. Only the Texas factory, and briefly Giga Berlin, experimented with a structural battery pack combined with both front and rear Giga castings. Tesla opted for a globally unified body design so that parts can be interchangeable across different factories, helping reduce supply chain risks. But why not switch entirely to front Giga casting? According to expert Luca Greco and the YouTube channel The Limiting Factor, Tesla is intentionally reserving its casting capacity for an upcoming, more affordable vehicle, CyberCab. As Elon Musk mentioned, the CyberCab could potentially be produced in just 5 seconds using the new Giga Press, highlighting Tesla's ability to create 5 CyberCab chassis in an incredibly short amount of time.
I think it'll be able to produce a car ultimately in less than 5 seconds. Like, can you imagine a car coming off the line in less than 5 seconds? That's like, whoa.
Producing a car every 5 seconds is something the auto industry has never seen before. And with the unique one-piece cast design of the CyberCab, it could become the only mass-produced vehicle capable of such a feat. When it comes to part reduction, an engineer on the CyberCab program revealed that the total number of structural components in the CyberCab will be around 80, compared to roughly 200 in the Model Y. That means the CyberCab will have over 60% fewer structural parts than the Model Y, simplifying the assembly and finishing process dramatically. For comparison, the Model Y, Tesla's best-selling vehicle worldwide for years, is currently produced every 35 seconds at the Tesla Gigafactory in Shanghai, the most productive car factory in the world. This shows that, thanks to the CyberCab's simplified structure and the use of the 50,000-ton Giga Press, cutting that down from 35 seconds to just 5 seconds is entirely within reach. For Tesla, technology isn't just for show, it's about serving long-term strategic goals, and with the 50,000-ton Giga Press and constant refinements throughout the entire production process, Tesla is gradually redefining what it means to be a car factory, a place where robots, artificial intelligence, and molten metal come together to build the future, second by second. Each CyberCab can be fully cast and rolled out in just a few seconds. No massive assembly lines, no need for hundreds of shift workers, just a fleet of robots, powerful AI, and a giant machine running day and night without pause. However, this is far from as simple as it sounds. So why is scaling up casting technology so difficult? Because it's an incredibly delicate thermodynamic process, performed under immense pressure. Molten aluminum is injected into the mold at high speed, and the metal must fill the mold perfectly and evenly before it cools and solidifies into a strong, rigid form. The larger the mold, the more complex the challenge. The metal has to travel farther, and the chances of defects increase. As we mentioned earlier, if it's injected too quickly, air bubbles can form, compromising the structural integrity. If it's too slow, the aluminum may cool before completely filling the mold. All of this happens inside a massive 50,000-ton machine. What Tesla is doing with the CyberCab isn't just about building a car without a steering wheel or pedals. It's about reinventing how cars are made. It's not just about redesigning the vehicle, but reimagining the entire production process. Instead of a traditional assembly line, it becomes a network. Instead of human workers, it's robots. Instead of hand-assembled parts, it's stacking pre-made modules, together like Lego bricks or toy blocks, just like Elon Musk said.
And that's actually kind of how they do it in like small volume castings. They'll like have a casting block that'll make like 100 Matchbox cars at a time. Maybe we just make that real big. Yeah, I mean, we have the Cathedral of Casting back there.
Yeah, Elon Musk actually compared producing the CyberCab to making toys. The only difference is that Tesla is scaling up the machine to build as many vehicles as possible. Once the Giga Press finishes casting 5 CyberCab chassis, they're immediately fed into the unbox process line, a system so fast that, as we mentioned earlier, humans can't even approach it safely. So what does it mean if a CyberCab is produced every 5 seconds? If Tesla sets it up like the current dual-line Model Y production at the Shanghai Gigafactory, but running at CyberCab speeds, then instead of one car every 35 seconds, 2 CyberCab lines producing a car every 5 seconds could output up to 178,000 CyberCabs per week. That's over 7 million CyberCabs annually in just 40 production weeks. Tesla has mentioned plans to produce 2 million CyberCabs per line by 2026. If the 5-second cycle time is accurate, they'll have to sandbag or artificially limit CyberCab production to avoid overwhelming demand or capacity. Lowering production costs will also massively increase both demand and margins for the CyberCab. But what excites us most isn't just that the CyberCab will be cheaper or faster to build. It's that its production model has become a whole new tool for global scale. This isn't just about a car, it's about the future of manufacturing. And it won't stop with CyberCab. According to multiple sources, the upcoming affordable Tesla Model 2 will also adopt a similar chassis structure. The only real differences? A steering wheel, pedals, and 5 seats. In the context of rising raw material, battery, and labor costs globally, Elon Musk remains steadfast in his claim that Tesla can indeed produce an affordable EV, leveraging technologies like gigacasting and innovations in the supply chain. Without gigacasting, this goal would almost be impossible to achieve. Like the CyberCab, one of the biggest advantages gigacasting brings to the Model 2 is the ability to drastically reduce production time to unprecedented levels. If the CyberCab takes 5 seconds, the Model 2 might take 10 seconds. Despite the overall decline in the electric vehicle market in the first quarter, the Tesla Model Y and Model 3 remain the best-selling EVs in the US. According to the latest report, sales of Tesla's 2 flagship models not only outperformed, but also surpassed the total sales of many other competitors combined during the same period. Specifically, Tesla sold 64,051 Model Ys, down 33.8% from last year, along with 52,520 Model 3s, showing an impressive growth of 70.3%. The Model Y may have slowed down as consumers are waiting for the upgraded version that was just released this quarter, while the Model 3 has seen a strong rebound. Additionally, the Cybertruck, despite being a newcomer to the market, has already achieved sales of 6,406 units, ranking 10th on the list of best-selling electric vehicles, while the Model S and Model X recorded 1,280 and 3,843 units sold, respectively. Despite facing some social pressure and opposition related to Elon Musk, Tesla continues to show absolute dominance in the EV market, thanks to its technological advantage, performance, and tightly integrated product ecosystem. That's all we wanted to share in today's episode. We hope you now have a better understanding of Giga Press, the CyberCab, and the Tesla Model 2. Thank you, and see you next time.